In the previous video, we went through what a reaction mechanism was and how to use one, but we're going to take a look at another example so that we can see how you would perform a reaction mechanism and then talk about ways that we can actually speed up reactions using the idea of the reaction mechanism. So this is the reaction mechanism I have set out for you, and like I mentioned in the previous video, you would never be expected to have to create this at a high school level. At least I would hope. For myself, my students, they wouldn't have to do this, but they would have to be able to analyze something like this and come up with an overall reaction and tell me the reaction intermediates. So let's do that. What we want to do is take a look at what we have before the reaction takes place in each step and after each step takes place. And then we want to find any substances that are both produced and then used up later on. So a good example would be this here. I like to call this Hoobr. So HOOBR is produced in the first step, but then Hoobr gets used up in the very next step, which means that you could essentially cancel this out. Now, I don't want to actually draw through it because it'll wreck my marker, but you would cross that out. The next thing we could take a look at is it produced HOBR, and it actually produced two of them. And here, HOBR shows up on that side as well, so on the left and the right. HOBR then shows up again in the final step. That means that we have two of them, so it means that both ended up getting used up. So those substances we would effectively cancel out. We would cross them off, and they would not be included in our overall reaction. What would be included is everything that's left. So if we take a look at what we have on this side, we have HBr, but we actually have 4 of them. So we add a coefficient of 4 to show that there's 4 HBRs. We also have 1 O2, so that's also going to be included in our equation. And on the other side of the equation, we have 2 H2Os, and we have 2 Br2s. Now, not only does this include everything from up here, as well as having those substances canceled out, it should actually be balanced. We have 4 H's, 4 H's, 4 Brs, 4 Brs, 2 O's, 2 O's. So our overall reaction is actually balanced. The other thing we can do is identify the reaction intermediates. The reaction intermediates are substances that get produced during the reaction and then get used up before the reaction mechanism is completed. In other words, our reaction intermediates in this case are the substances we canceled out. HOOBR and HOBR. There were actually 2 of those produced as well, so and 2 used up. So those would be our reaction intermediates. The reaction intermediates will always be the things that you cancel out, and they are always products the first time you see them, reactants the second time that you see them. So they always get produced partway through the reaction and then used up. Now, something else we can do with a reaction mechanism is figure out a few things about the speed of a reaction. So let's take a look back at the example that we did. So if we were to say that the first step was slow and then the next 3 steps were fast, you may think this is a relatively fast reaction because 3 of the steps go quickly, but 1 of the steps go slowly. But this totally changes when we actually put in numbers. So let's actually put in some speeds for this chemical reaction. So let's say the last step takes 6 seconds, and then the third step is the same. It's 6 seconds. Let's say the second step only takes like 0.1 seconds, but then let's say the first step takes 1 year. All of a sudden, this no longer looks like a fast reaction. The other thing you can see is that it doesn't matter what you do to try and speed up these 3 steps. What you really want to do is focus on this step. Step 1 is what we would call the rate determining step. It is the slowest step, and the slowest step always determines the speed of the reaction. Think about the rate determining step like ordering fast food. Imagine you go to a fast food restaurant, you put in your order, at the back the cooks make it, and then a person packages it in. That's kind of like a 3-step reaction mechanism. Order, make the food, package, and hand it to you. Now imagine that the cooks are working extremely fast, the person packaging them up is going very, very quickly, but the person at the counter taking your order has a long conversation with each customer, making the experience go very, very slowly. If you wanted to speed this up, it doesn't matter if you speed up the cooks or if you speed up the people bagging your food. You need to speed up the person who's working at the till. That is your rate determining step. And much like in chemistry, if you want to speed up the overall production, you need to speed up that step and focus your energy there. Just like with our example, if you wanted to speed up any step, you would make sure that you speed up the slowest one, because the slowest one is your rate determining step and actually determines how fast the reaction is going to take place. So thanks for watching about rate determining steps and reaction mechanisms, and I'll see you next time.